But what it then boils down to again is the human element, that human input. You need people with a deep understanding of the problems. It needs people with experience to be able to manage and administer the solutions to the problems that we overcome.
If you're going to host a podcast, make sure you always cover subjects you know something about so that you can engage with your guests and make sure you don't look a fool when asking questions or inviting healthy debate. Well, let's try something different this week and go with a topic that I personally know very little about, even though we touched upon it in episode 25, Capturing Reality with Derek Lawrence. Check it out, it's amazing. This week, we're looking into the world of geospatial solutions and whether it's just for those big ass projects we're accustomed to hearing about via our favorite construction media, Construction Wave, and this podcast, of course, or if there's wider scope here where this type of technology is accessible and affordable for most and usable on projects both large and small. Now, I'm being slightly flippant in that most, and I'm including myself in this most, have heard of the likes of Google Earth and projects such as Earth 2, which could be categorized within the geospatial sphere. But from a construction perspective, these don't offer the sector-specific solutions we need within construction. To put simply, we need to chat with somebody who knows what they're talking about within this area. Stuart Gilling is the Managing Director of Malcolm Hughes, geospatial consultants specialising in the capture and processing of measured data in all environments. Stuart also bears the title of MRICS Chartered Surveyor, Geospatial Solutions, and Consulting RICS Registered Expert Witness specialising in boundary dispute resolution. Prior to this, Stuart initially managed the CAD production team and was instrumental in the adoption of BIM across the business and the adoption of drone services. With 17 years' experience in the geospatial profession, Stuart also completed a management and logistics degree, followed by a master's in business administration, becoming a member of the Chartered Institute of Civil Engineering Surveyors in 2006. Stuart, welcome. And was there anything I missed off that intro?
Nothing other than it's 20 years experience now, so a little bit out of date on my CV somewhere. Apologies for that.
Yeah, absolutely nice. Nicely pointed out. Thank you very much.
No trouble.
Yeah, okay. Let's get into this then. A little bit of a preamble before we get into the details, but I just want to highlight that in this industry, the construction industry, spatial awareness and precision is like paramount on a lot of projects. And geospatial analysis has emerged as a bit of a game changer, I would say, for most people. The global market for this area is poised to reach, and this is the research talking, 124 billion by the end of the decade. Its impact on construction is undeniable, and it will be undeniable, but maybe confusing to some, and I'll place myself in that. So let's just start with the basics. What is geospatial analysis in the context of construction?
Okay. Geospatial analysis, it's you're right, it's a bit of a buzzword locally recently. I would say geospatial analysis is an incredibly broad subject that encompasses everything, but in a nutshell, you can boil it down to what I like to refer to as location intelligence. So it's marrying information, metadata, properties, that kind of data with physical location in a real world environment. So that can be through a number of means. That's either conventional, in modern terms, conventional CAD drawings, moving into 3D models where you're encompassing the time element in a construction project, for example, so the phasing of works and the transitioning and progression. But also including things that are sort of less obvious. So, for example, we do a lot of work with highways, so we're mapping and modelling buried utilities that are running underneath the carriageways, and need maintaining, all of that kind of thing. So we build a picture that encompasses all of that intelligence married to a 3D coordinate so that you can locate that in real space and real time.
That's cool. So it's like 3D, where things are to provide intelligence. That's kind of what
Exactly. Yeah.
I'm getting from it.
Yeah.
That's great. I mean, my next question is more about the tech behind it, I suppose. So if you're looking at, regardless of whether it's small renovations or massive infrastructure developments, this kind of analysis, I suppose, can help projects of any size. And I think we
Yeah,
can.
absolutely. Just sorry to cut in there.
Yeah,
There's a
absolutely.
couple of really relevant examples that spring to mind.
Oh,
So
please.
there's some recent works we've done on a sort of micro scale like that. We've been locating underfloor heating pipes within a business premises. So we're looking to relocate some of the walls and so on. And clearly, you don't want to core through underfloor heating because it's going to cause you all sorts of troubles. So we went through a process using ground penetrating radar of mapping the area to identify that information. So on a real micro level, we could say within any 6-inch square where the pipe was for them to be able to avoid that feature. So it's everything from grand scale national highway infrastructure, multi-story buildings, all of that kind of thing, through to the real micro detail in that. Where is the pipe within the concrete slab? Where is the rebar? Where is this, that, the other?
I think that's the bit that people might not get straight off the bat until you explain that. Is that when we first started talking about what it was, we're talking about big projects, and you're saying infrastructure and highways and underground and pipe works, and straight away you just think of motorways and large scale projects. But did you say around about 6 inches? It was.
Yeah, I was just giving an example of, I was trying to think sort of in sort of micro terms within a floor tile, a typical 6-inch squared floor tile, 150 mil square floor tile. You need to know precisely where that data is, so we were able to work to that precision, that accuracy, to be able to identify these features.
Yeah, brilliant. So moving on to the actual technology then behind it, what are the fundamental tools and software and data sources that are readily available and accessible? And is there any complications with the things like legacy data systems to get the most out of this kind of tech?
Legacy data can be problematic. I mean, you can work with most of it to varying degrees. We, in most instances, would always like, from a liability perspective, want first-hand observation of that data and that information. But the principal tools that we use within the geospatial industry are GNSS, so the modern global navigation satellite system, the replacement, if you like, for GPS, which is a proprietary American system. So the GNSS systems now using multiple satellite constellations to give real-world position. Total station using angle and distance observations, trigonometry, that kind of thing, to calculate coordinate. A huge amount of laser scanning these days. So we deploy multiple scanners. I think we've possibly got one of the largest fleets of Leica RTC 360s in the country. We're currently running 14 of those. We have larger scale, heavy duty sledgehammer laser scanners for bigger range, higher density data, that kind of thing, through to mobile systems, vehicle mounted for, as I say, for mapping highways and large areas very quickly. But we also have recently invested in something called a Navis VLX3, which is a wearable solution, has a shoulder and waist belt mounted exoskeleton. It carries 2 individual laser profilers that measures in 2 different planes, and then an array of cameras around, sort of sat above your head. So as you're walking around through a building or around infrastructure, it's using something called GeoSlam, which is simultaneous localization and measurement. So what that's doing is it's using accelerometers, IMUs, to track your movement and your trajectory as you're walking. But it's also capturing data, and then it's using the data that it's observed to help position itself relative to its previous location. So it's building up that 3D model in a geometric sense, but then also validating that using the accelerometers to track your position and your movement, your heading and your bearing, that kind of thing. That's a bit of a major turning point for us in terms of survey, in that you're at a point where we're getting very, very close to the accuracies that can be achieved from conventional tripod mounted laser scanning, but in a far quicker, more efficient solution that brings multiple benefits, in that we're able to capture data faster on site. That reduces our surveyors' exposure to certain environments. It means that we have less impact and less hindrance on clients and occupiers of those buildings and structures. And also then gives us a solution where that data is easily shareable with stakeholders within the project.
I was just about to ask that. In terms of all the hardware and software that generates this information on a site, is it almost instantaneous in terms of it goes from capturing it to what you see on a screen, and then delivering it to a client or discussing it with somebody? Is that a pretty quick process?
It's getting quicker. The process has been, historically, was quite lengthy. The download and import of terrestrial laser scan data has been a bottleneck for a number of years, and it's becoming worse as the scale of the projects and the volume of data and the deploying of laser scanners, because of you wanting that rich data set. It's kind of a play-off between speed and efficiency and content, in that, do you target in specific features, specific observations, or do you capture everything so you've got it all in the can and can produce whatever's needed at a later date? Navis, and through Ivy and their processing software, has streamlined that process, in that it is now it's not automated, but it is a semi-automated process. So you bring data in, there's still a download or a copying process and an import process, but it's swifter. But now, rather than relying on human power to place one scan relative to the next, or tie one scan to control and so on, there's a cloud-based, AI-driven solution that takes the data, you input some parameters, you input some control settings and files and that kind of thing, and then that's sent off, uploaded to the cloud. And the beauty of that really is that can be processing and churning whilst you're sleeping. So in theory, depending on the size of the project, back in the office the following day, and yes, you can be interacting with, sharing, discussing, working with that data far quicker than you ever used to be able to.
I'm glad you brought the human element into this, because that's, the more I discuss technology within construction, it always brings back to the human element, which is quite fascinating. One thing that I want to touch upon now is the PAS, and correct me if I'm wrong here, I think I've got this right, but the PAS 128 standard has emerged as a key player in what you do, and this outlines best practice for utility mapping. However, its implementation and verification has been a bit of a concern, which has brought in Puma 128, which is PAS 128 Utility Mapping Accreditation, a scheme developed by the Survey Association in conjunction with the LRQA, Lloyd's Registered Quality Assurance. That was a mouthful for me. So to kickstart this part, could you explain the significance of my ramblings there, and more for my own benefit, what the hell have I just asked you to explain.
No, I'm going to complicate that further. I'm going to throw in another acronym for you. So
Brilliant.
there's been the Geospatial Commission within central government have recently been working on a project called NUAR, which is the National Underground Asset Register. Whilst PAS 128 has existed as a standard, traditionally suppliers, holders, owners of assets and infrastructure have a legal obligation to maintain a record of that. Those records have traditionally been somewhat lacking. It's probably the politest way of putting that. You're working off Ordnance Survey data that has inherent accuracies, or you could say inaccuracies within it, but it's not designed for the precision that's needed for locating specifics within the sort of accuracies that we need within the industry. So that's a project to try and improve that process, and PAS 128 feeds into that. But off the back of that, that energy, that impetus, the development of an accreditation is trying to feed information into that register to make that as robust and accurate and up to date and available as possible. So basically, PAS 128 is the national standard for the mapping of below ground utilities. Within that, there are different levels. So, for example, it goes through from a level D through to a level A, or type as it's referred to within the standard. So type D is relying on those asset registers, the records, that kind of thing. So it's normally a PDF or a paper copy of a plan with big thick fuzzy line on it that sort of makes some sense based on the features you're seeing on the ground, but you can't ever really locate it with any confidence. Through to a type C survey, which is working with that same information but applying human input, human intelligence to analyze that against physical features on the ground. So you would undertake a process, normally a site-based walkover, where you're identifying the physical presence of those services on the surface, so the covers, the chambers, the inspection points, that kind of thing, and saying, oh, clearly, actually, no, that gas that's seemingly in the carriageway may be actually in the pavement, and that runs between these features here, that kind of thing. The type B is where we principally get involved as Malcolm Hughes. So this is the non-intrusive location and recording of those features, and we deploy a number of different pieces of technology, but principally EML, electromagnetic location techniques. That's where you use a tool that has a signal generator and then a receiver, and you access the individual cables, pipes, whatever that might be, and you introduce a specific frequency into that feature. Tune the receiver into that same frequency, and you can follow its route at surface level and plot the depth based on the strength of the electromagnetic field and so on. Supporting that, I should have said at the very beginning of that, the first thing you do is let that type C survey. Your drainage surveys, for example, which are a component of your type B, typically rely on that human input. That's manpower, lifting manhole covers, using experience and intelligence to understand what they're looking at, and then mapping those routes between adjacent chambers and so on, following that process through. The third tool that we use in our arsenal for this is ground penetrating radar. So that's a device that sends radio waves down into the ground, and based on the density or the reflectivity of the features that it's locating. I'm just going to caveat what I'm saying by saying I'm not an expert in ground penetrating radar. There are a lot of contemporaries of mine within the industry that are, but my understanding is radio waves sent down into the ground, you're measuring the disparity in density between the surrounding earth and the material or the product or the feature that you're locating. And that will display on the screen in a parabola that enables you to, with some understanding and training, some ability to identify where a feature may be, an approximate size, a depth, that kind of thing. Within the GPR technology, so AI is becoming more prevalent within that solution at the moment. So you can run over an area, you might see with the naked eye a number of these services, a number of these features that you're identifying. But the AI, because it's had hundreds and thousands of radargrams and pieces of information pushed through its learning processes, it will also help you to identify a lot more. And the solution that we use at the moment is a Marla product, and that gives you a little dot on the screen where it thinks there may be a service rather, and enables you to drill into that with other means to identify it. That information is all marked at surface level. The radar data we capture for post-processing purposes as well, because whilst you're pushing the device along and you're seeing a single swathe, you're not always seeing the whole picture. So by recording that data and its location, to go back to the location intelligence comments earlier, recording the data and the position, you can build that data up into a big 3D model, and you can then understand the interaction of those features in different directions and so on to identify further what might be below the ground. That's then all presented in CAD formats, 2D, 3D as required. And then the final layer really within PAS 128 surveys is a Type A survey, and that's a physical verification. So that's breaking ground, normally with a vacuum excavating team. So they use high pressure water and vacuum to break the ground and remove it. So very low chance of causing damage to the apparatus below ground and so on, but physically expose the services to verify the reliability of the previous surveys that have gone before and give you absolute confidence on where key infrastructure might be.
The more I talk to people about various technology and sectors within the construction industry, the more it always surprises me the complexities and the details that go into each individual component, and the variety of things that can happen just in this small section of the I mean, it's big, but small section of the industry, if you like. That brings me really nicely onto another thing that, as you were talking about all these various components and levels, is this potential for commoditization. I think we can all agree. I've said this time and time again, but within construction, cheap isn't always the best solution. But we seem to have this thing with cost and reducing and cutting and cutting and cutting, to the detriment of a whole host of things that shouldn't be at the detriment of. I'm trying to link this to what you do, and the closest I can relate it to is things like Google Earth Pro and how accessible that is from a commodity basis. You know, anyone can dive on there and look and scan round in a digital world that, you know, practically the entire world. Do you see a future where a lot of geospatial, maybe not the analysis, but certainly the creation and some of the analysis is starting to become commoditized and then cheaper and not as effective? And do you think that both can coexist, be it the bespoke solution that I believe every single project needs, compared to the likes of a Google Earth coming in and saying, we've got all this info for you?
Yeah, I mean, there's clear value in that. I mean, you've hit upon one of the principal issues, I think, from what I experience, at least within geospatial and within using BIM as the primary example. The 2016, I think it was, when the government mandated that any publicly funded construction project over £2 million had to be developed using the BIM process, and that was about collaboration, information sharing, central resources, minimizing reworks, clashing, all of that kind of stuff, to try and drive down the cost of publicly funded projects. And whilst it does work, and is extremely effective. It's most effective when partnerships are in place rather than the sort of more typical supplier solutions, supplier arrangements, that kind of things. Where we see best value for our clients really within this sort of area is when we are invested in a project, and you're never really going to get away from it, but when you can remove the commercial element of it. So the way that things seem to be at the moment, and this is sort of the big barrier to the utopia, is that you price against a number of competitors for a defined piece of work to a given specification. You're removing value engineering opportunities, you're removing this, that, and the other, because, as you said, most of it is driven by price. So as long as you're all working to the same information at tender, so you've got the same requirements that you're seemingly pricing to, it 9 times out of 10 boils down to price. So, or pre-existing understanding of the project is probably the only time where price wouldn't be the principal driver. But you get into a situation where it's a piece of work for a defined sum of money, and then some more work appears that is needed. So then there's another tendering process for another piece of work and another piece of work and another commercial arrangement and so on. Whereas the way that BIM should work when it reaches its full maturity is by each stakeholder, and I include geospatial providers within that, each stakeholder feeds into that central model with equal responsibility, with equal ownership and understanding of the importance of that data. That's where that process will really start to make really significant strides forward. But whilst survey is surveys often seen as something that is essential, but is often the very last thing that's almost the very last thing that's considered in any project. So I don't think there's ever been a project that's been built, designed, constructed, finalised, maintained that doesn't have surveyors involved in it in every step of the way. Before you build, before you design even, you need to know what's there. You need to know what the ground's like. You need to know what services are there. You need to know the topography. You need to know the structural makeup. All of that kind of information is key. But what we see in our industry is really significant projects coming through with horrendously tight timescales, with not fully developed specifications for the survey, because it's been a last minute thought in the process. And then that causes problems in that you go through the process and, well, actually, no, you didn't ask for that tender, so therefore we've not quoted for it. And you get into this sort of process of small contractual adjustments, small pieces of additional work to feed the bigger picture. Whereas if everybody came together at the beginning with surveyors, with ground engineering, and with ground engineers and the like, being involved in that whole process and feeding into that design process, if you like, the specifying process at the outset, you'd minimize a lot of those disruptions, those delays, those shortfalls in information and so on. So yes, there would be a need for it. There would be a big uptake on the usage of commoditized data, but until we get to a point where it isn't just transactional, I think it's a bit of a utopia, unfortunately.
Yeah, absolutely. I think a lot of things in construction can be classed as that, and it always comes back to a collaborative approach, and open dialogue and communication that seem to be key, which seems to be for reasons that are a bit of a head scratcher, difficult to achieve within construction, particularly, unfortunately. I just want to finish off by looking towards the future. And within construction, we're always looking at ways to optimize, be it efficiency, safety, sustainability, clearly cost being one of those. And I think that geospatial analysis holds quite a significant potential for growth within construction and what that can actually achieve and help people achieve through a whole host of different things like planning, design, execution, maintenance, loads of different things. For your own words, or from your own words and thoughts, what do you think the growth opportunities are, and is there anything holding us back from growing at an exponential rate in this area?
I think the biggest barrier, as I said a couple of minutes ago, it's that transactional relationship that tends to exist. So until everyone involved in the projects, from the architects, the structural engineers, the construction teams, the design build companies, all the rest of it, until everybody is all on the same page and working properly collaboratively, then significant strides forward are going to be difficult to achieve. Other barriers, I don't know. It's that side of things, really. It's the commercial and legal tie-up that is that biggest barrier. Technology is definitely not a barrier. Like, there's huge strides forward. The likes of in my industry, the primary suppliers like a Trimble, all those kind of guys, they've done huge development in making the equipment more robust, easier to use, more efficient, that kind of thing, lighter weight, quicker data imports, exports, all the rest of it. So I don't think there's a huge amount to come, really, within Geospatial itself. It's more that bigger picture, that understanding. So it's for me, the future is about partnerships rather than transactional arrangements. I think that's the key.
Yeah, for sure. And in terms of the technology, I think people can get very carried away and be futuristic and see too far into the future and what that could potentially bring. Bringing it back into the near future, is the future of the actual technology that you're utilizing and people are bringing out and updating? Do you see that being more improvements in speed and reliability rather than this futuristic, it's all going to be done by AI and click of a finger and it's there and it's updated?
Yeah, I don't know. There are some interesting developments within Geospatial. So there's a bit of a push at the moment with AR in particular, augmented reality, so headsets and that kind of thing for visualizing new structure and the like within a building. There will, I believe, be a time where setting out engineers as an example, where their role is somewhat diminished when this AR solution drills in and gives you the precision and the accuracy that's required to do individual setting out directly from the headset through a heads-up display type solution. That has real potential. Timeline on that, I've got no idea, but yeah, it's I can see that happening potentially. But what it then boils down to again is the human element, that human input. You need people with a deep understanding of the problems, all of the learning that's gone before. You can't replace all of that directly with machines because it is variable. It is in difficult conditions, in difficult environments. It needs people with experience and people with deep understanding to be able to manage and administer the solutions to the problems that we overcome. And I think there's a real risk with, we talked about the developers, the software and hardware developers, making things easier, making things slicker. Like some laser scanners now, it's 2 or 3 button clicks and you're scanning, you're capturing data. But it's understanding the first principles of how to build that system, what's required in terms of how do you develop that primary network so that you've got that assurance, primary control network, I should have said, so that you've got that insurance over the accuracy of that information, so that it is repeatable, so that you can create the precision that's required within the projects and so on. You're not really going to be able to replace that with technology and sensors and the like. It still needs that human input, that design element within it. And there is a risk that by technology being more available, the barriers to entry are relatively low within our industry. If you can understand the fundamentals of what you're doing, you can effectively be a surveyor. You can go out and capture data and deliver it. But I guess like with any profession, it's a case of being able to understand why you're doing something to prevent a problem occurring later. And as I said, with surveyors being involved from a very early stage within a project, and also throughout the project in terms of the construction phase and so on, mistakes are costly. And if you don't understand what has caused the mistake, then you can't rectify it and you can't mitigate for it in the future. So yeah, I think humans will definitely still be central to our industry, our profession. Technology is there to help, but it's not a replacement.
That's fantastic. That's a great way to end it, I think. Technology is not a replacement for humans. I agree. It's to make our lives easier and more efficient and do better at what we can achieve as a human. Stuart, thank you so much. It's been an eye opener for me to look at the technology and what you do and what the future holds. So thank you so much for sharing all that vital information. It's been a pleasure.
No problem at all. Thanks very much. Same to you.